When it comes to the long-term studies, really when we're trying to assign efficacy of a product, it's built on a meta-analysis of multiple studies, but the reality is we simply don't have the number of long-term studies to build into those. What is really the limitation, or when are we going to be able to assign efficacy to a product without the number of long-term studies to build into those? Anybody?
We need the studies, but all of you know what is to do a full lactation study in a university setting. I mean, you can do it on commercial farms, but that's even more difficult. So we just don't have the data, unfortunately. And until we have the data, in fact, every project that is funded about methane nowadays should have a long-term study included. Those of you that are involved in funding, you should definitely look into that in the future. Without data, we can't say anything.
Yeah, I think it's important, some of the discussion that happened earlier today, right? So the bigger pictures, we have a lot of climate commitments, we have a lot of expectations that we're going to reduce emissions. Feed additives are one of those ways, but if we don't have good confidence that they work in a commercial environment over the long run, and that we can truly point to reductions that everybody can agree on, and we don't have greenwashing accusations, that's going to make it really hard to counter an alternative perspective that the easy way to lower methane emissions from ruminants is simply get rid of ruminants, right? So I think just to put maybe a little fire into that comment of like why it is so important that we have longer term studies and really nail down standards for efficacy. I think that's important as a scientific group to come together and create those standards.
Yeah, I'll just say at Cornell, I don't see myself ever doing anything over 12, 15 weeks. And I know that's just not going to happen. We just don't have the capacity to do it. I mean, we have 60,000 dairy cows within an hour of Cornell. So I would think we could probably figure out a way to work with them better. But at Cornell, it's not going to happen.
But you can add to that. Of course, I agree that the long-term studies are important, but researchers will always ask new questions. So you could also ask a question, will this feed additive have an effect on reproduction? Then you might need to do a study for 4 years or 5 years, and I don't think we can wait. So I think we need to get some of these products out to work, and then we will have to evaluate them while we're implementing them at the same time.
So as we do...
And you brought a good point with reproduction. I mean, that's something you cannot ever do in a university setting. It's got to be on a commercial farm. And where is Mike? Mike knows years ago we talked about 3-NOP and reproduction and all that. And of course, we can never do it because who is going to throw milk from 2,000 cow dairy farm?
So if we're kind of building this plane as we fly it, and we get the initial data, when we need to accelerate action, deployment of these products, but we need to be constantly evaluating them on farm. How do we do that while maintaining the trust and the durability of this emerging marketplace?
Yeah, so we think about a lot about this topic, the consumer trust at Cornell. I mean, Cornell and RBSD had a long history together, and this is something we always talk about. And it's like, hey, I don't want to be 10 years from now or 15 years from now, and this is another RBSD kind of scenario when we're talking about bromoform. And so we've got to be, at least the only thing I do is, I mean, I think most of us all do it, is trying to be as transparent as we physically can be at every step of the way, doing our best to really prioritize safety and health. I think that's maybe something we can learn about the RBST sort of scenario and say, what could we do differently to make sure we don't repeat the same mistake?
I think it is a central challenge because it's very difficult to measure methane emissions even in a research environment, let alone in a commercial environment, right? And so I think that's part of our challenge is even in the research committee or community creating more standardization about how we're measuring methane emissions, particularly, I mean, we're very dependent upon green feed machines, but there's many different protocols that everybody is using in terms of how many spot samples they're taking and making sure we have transparency in how we're divulging those type of things, even in a research setting. So it becomes more complex when we go to farms, and I think that's one of those serious challenges that we need to think about, right? And there's a lot of great work that's been talked about of coming up with better prediction equations, and that's going to be a really key part of it. But also in any other way, shape, or form that we can actually verify that methane reductions are taking place, because there will be incredible scrutiny on this as these things become commercially available. Any pitfalls or any places where it doesn't actually seem to work on farm will be latched onto in many cases as evidence that maybe we shouldn't be investing in the space. So we have to really take that real seriously.
So speaking of investment in the space, over the past several years, we've seen quite a significant increase in the interest, new players in the field, new researchers entering the space to try to investigate feed additives. And the reality is now we're starting to see a bit of duplication in the literature regarding what studies are being done and the different additives that are being put on board and evaluated. How do we ensure that the studies that we're doing today are adding to the scientific conversation and not simply being done because someone got a grant to do so, right? And actually building on this conversation moving forward?
Oh, I don't know how, because there are 1,000 journals out there, and everybody can publish anything nowadays. So the criteria, the bar goes pretty low nowadays with these things. So I will say this though, as you probably all have seen, there is a lot of products out there, a lot of companies coming out with claims. All this, if it's not tested and confirmed in controlled independent studies, doesn't really matter. And again, I will cite DSM and 3NOP. I don't know how many studies are there. And after so many years, the first paper we published was 2015, and the study was 2013 or so. 10 years later, this compound is still not approved in the US after tens of studies published in good journals. And you can't come out with company data or on-farm data and make a claim without this being confirmed.
I mean, talking about the number of startups that we probably all talked to over the last 3 years, it's crazy right now. And I think what we got to do a better job of doing is really picking winners earlier on, and really not investing in stuff that's going to give us sort of nominal or potentially no gains at all. It's really concerning, to be frank, the claims part. I mean, we've all either people in our office or on the phone, and you hear the claims. We have a Grow New York competition in New York. Every year, Mike and I come out of the hall and we talk to each other, Van Amberg, and we're like, yeah, somebody's using our name again, and they just got like a big grant or something. And it's like, it's sort of out of control in a way. And so we have to be really careful. We really got to be sort of selective, because it doesn't take a single study to get something approved. It's going to take a really concerted effort, a really streamlined approach, a sequence of studies to really accelerate a specific technology. And we're not really doing a good job at that right now.
Dr. Lund, do you want to add on that?
Yeah, maybe to say that I'm very fond of working with these small companies, because sometimes we can get a little bit, what is the English term, narrow-minded, focus on ourselves in academia, that we have all the solutions. And sometimes it's actually quite nice to meet these people that come with a total different mindset and have a rather crazy idea, and then we can test it. And no, it didn't work. And science is also about shooting down ideas. All of us want to find this perfect additive that reduces methane with 70% or whatever, but half of our work is actually shooting down ideas. And we should do that as well, because then we can focus on what actually works.
Agree. There are additives that, seeing something for the first time, I totally get it. It's the thrill of discovery. But if it doesn't work, I see scenarios where there's funding for these technologies. I'm not going to name a name, but you see something that doesn't work, and all of a sudden you're 5 years into something, we got 10 studies and it just doesn't work. There's no convincing evidence.
And that you can see that company have in some kind of carbon trust company, you can say that they can claim an effect. Yeah, I have never really understood that.
Peter mentioned something here about additivity and combining feed additives that I just want to comment a little bit. Like this climate smart commodities grant we have. You know, the farmer sees a list of things to do on manure, to do on nutrition, or the, you know, growing the plants and so on, to pick practices that they can use. But there is absolutely no data if they pick 2 or if they pick 3 or if they combine manure with feed, with growing the crops out there. So there is tons of things that are still missing in the methane and greenhouse gas field in general.
Please.
Yeah, I would just echo that, and I think there's lots of examples there on the beef cattle side as well of things that we assume make an effect or can reduce methane emissions, and we saw some of those outlined, but there's very few of those kind of experiments that actually look at seeking if they are additive, and so that needs to be a key focus of that research going forward. I also think a lot of the comments about different additives is, I mean, the success of 3-NOP and the reason that molecule works is because it's taken a mechanistic approach to understanding what's actually happening with methanogenesis and targeting the enzyme and going at it in a logical fashion. And I think that's part of this space as it, at this point, I would hope matures further, is we're less just throwing spaghetti at a wall, but more actually thinking about what's taking place within the rumen. And as, you know, metatranscriptomics and all these new ways of discovering and understanding what's actually taking place are advancing, I think that's that key opportunity, is to take in a mechanistic approach and stop just trying multiple things, but really focus in on what's actually happening in the rumen.
So we've heard today also about early life interventions and programming of the rumen, combination approaches, even potentially dose cycling, but also what hasn't come up today is potential delivery mechanisms for our cow-calf operations, our beef systems, our grazing systems. And with things like that in mind, what is the next bastion of research for this area that isn't getting the attention? Support that work.
Maybe say when I talk to Danish stakeholders, they say, if you don't, within 10 years, or you or somebody else in the academia comes up with a feed additive that can reduce methane, or a combination of feed additives that can reduce methane with 70%, we don't think we are in the market. That's what they say, the stakeholders. So for me, the one who can find a combination of feed additives that can reduce methane with 70% without any negative effect on feed intake, that's the solution the stakeholders want.
I think the delivery is very important, just because even here in the United States, 80% of our enteric methane is coming from animals that are grazing, right? So we're all the same in terms of developed or developing countries in that way, right? In terms of ruminants are primarily grazing, and it's very hard to control what they're consuming. I mean, we have a hard time still measuring intake from a research perspective, right, in those settings. So whether it's bolus technology, or we can imagine trying to do things like dosing in water, but this discussion about regulatory approval, we can imagine that would be really hard if you cannot control dose, right, in water, for example. So there's many technical things to overcome in this space, but we do have to think hard. You know, the earlier discussion about genetics is one key opportunity, but we really have to think hard about what are the solutions that are going to work in that grazing setting, and a part of it is a molecule that works, but then also how do you get it into the animal in a reliable fashion? I don't think there's a clear answer right now.
Certainly this is the next challenge, or one of the next challenges in feed additives, how to deliver it in systems that the cows don't see feed you know, on a regular basis. And I know that there are companies working on this for certain feed additives, and they are not there yet, but they are working on it. And I think probably in the next year, we'll see something coming out of that.
The only thing I'll add is the India component here. I mean, 75 million farmers, 1 to 2 animals each. They have, I saw probably dozens and dozens of compound pelleted feed there of different varieties. Like, how do you get something out there in that kind of system? That's going to be a real challenge.
With that, I know we're very tight on time, and we're going to move into our next panel. But I would like to, for everyone, to thank our panelists for this session. Thank you very much.